Hi students, what I would like you to do for these notes today is to follow along and open up your Desmos activity as well. So it says I can use scatter plots to describe the relationship between two data points, and that should be two data sets. And it goes through the three types of correlations. There's a positive correlation when the y values tend to increase as the x's increase. So positive is when you have both data sets increasing. Think about the hours after the sunrise. 6 o'clock, it's kind of chilly outside. 7 o'clock, it's a little bit warmer. 8 o'clock, it's a little bit warmer. 9 o'clock, 12 o'clock, 2 in the afternoon. So that's really a positive correlation because it's trending upwards. It's going up and to the right. You can think of it, if we drew a line like I just did, it have a positive slope. Now, a negative correlation, on the other hand, is when the y values tend to decrease as the x values increase. And this is just one type of example. Think of the hours after a sunset. The sunset happens at, let's say, 6 o'clock at night. It's 50 degrees, and then at 7 o'clock, it's now 57. At 8 o'clock, it's 52. The temperature is decreasing. So one of the data sets has to increase, the other one has to decrease for it to have a negative correlation. And think of it, if you drew a line through this, it would be a negative slope. Now, no correlation is when really the x and y data sets don't have anything to do with each other. There is no relationship between the two. Notice that it says the amount of rainfall in the hours after sunset. When you kind of like chuckle and you kind of like, that doesn't make any sense, that's usually the no correlation. Now on the next slide is the matching. So notice right here, the yellow dots, they're all scattered. They kind of look like they're going up, and then maybe they look like they're going down. They're kind of scattered all over the place. There's really no sense of direction. So that's why we call this one no correlation. Now notice my green data points are trending upwards. As the x's are getting bigger, so are the y's. Both things are increasing, so that's a positive. And then this dark red, purple color is trending downward. It looks like a negative slope, so that would be officially the negative correlation. Now, in the first slide, I talked about the trend line. The trend line is just an equation. It models the data in a scatter plot by showing the direction of that data. A trend line will be in slope-intercept form. So if we were in class, we would probably make you plot the ordered pairs on a graph and then draw a line of best fit. So trend line and best fit line of best fit is the same thing. So sometimes I'll use the line of best fit, and sometimes it's a trend line. Line of best fit is exactly what it sounds like. It's the line that fits the data the best. Now, scatter plots are all about relating the two variables together. So in this table, it shows the amount of time required to download a 100 megabyte file for various internet speeds. So we're going to create a trend line to represent this data. So now we have the internet speed. You want to glance and see what the table's doing. It starts at 35 and it goes to 60. All right, so that data is increasing. 35 to 60, getting bigger. But then look at the time to download. 6.65 all the way down to 3.88. So that's going downward. When you have two data sets like this, that one goes up, one goes down, you should think in the back of your mind, I think that's going to be negative because one piece of information is increasing, the other is decreasing. So let's see if we are correct in that assumption. So I recommend writing down the table or flipping back and forth between the slides or even taking a picture, because in the next slide, you're actually going to input the data. So the table is already set up for you. So from there, just start typing, even the decimals. So you don't want to leave any part out. So the 6.65, 40, and be careful, make sure you do the decimals, because I just wrote 517, that's a big difference. Okay, so once all the data points are in the table, I want you to look at a few things. Right here is r squared and r. We're not going to deal with that at this moment, but this part, the parameters of your line, shows you the m and the b, your slope and your y-intercept. So we'll take a look at that in a couple seconds, but I want you to actually look at what Desmos did. So what Desmos did was plot the ordered pairs that you put on the table. And then it created a trend line, or a line that best fits the data. If you zoom in a lot, you'll notice that the line is not really on the points, because this is a real set of data, so it's not going to be exact or perfect. But it's actually very close. So we actually call that a strong correlation. And notice that it's going downward. Remember that up arrow, down arrow that I showed you? It's actually a strong negative correlation, which we'll get into later on in this unit. Now, from the previous example, what is the equation of the trend line? So I actually took a picture of the numbers. So it said our m value was negative 0.109371, and our b value was 10.2618. Now, please don't write all of those numbers down. I'm going to probably make you round to the nearest hundredth. So that's our second decimal place. So we're going to have y equals negative 0.11 x and plus 10.26. So just make sure you have two numbers after the decimal. Now it says, does this situation represent a positive, negative, or no correlation? Now let's think about this. As our internet speed was increasing, our time it took to download was decreasing. Also, look at our slope. It's negative. So since it's a negative slope and we have one piece of data increasing and one decreasing, it's going to be with a negative correlation. As the internet speed is increasing and the time to download is decreasing. So I have the word negative. I have one increasing and one decreasing. So you want to be as specific as possible there. All right, let's try one more example. You can try to hit pause and try to do this on your own and then hit startup. So once again, a trend line is exactly what it is. Now think about this table, the hours of studying and your test score. So we're going to figure out the equation of a trend line, or the trend line, best fit line. And think about this. We're going from 6 to 9. That number is increasing. Our test scores are going from 77 to 92. That's also increasing. When you have two sets of data that are increasing, you're going to have a positive correlation. So let's confirm that our line is going to be positive, and let's confirm that our slope is going to be positive because that's related. Okay. So I took a picture of the data points, and now I'm just going to enter them. And it's okay that the 7 repeats. You want to write exactly what the data says. So there's no need to write it once or anything like that. That's not what we're doing for this lesson. Okay, once again, we're going to ignore the r squared and the r. If you don't see the points, all you have to do is kind of zoom back. Notice that the points, think about the y's, they're all the way in the 70s and all the way to the 90s. So we got to go a little bit higher to see them. So once again, those points are very close to that line. That is why it's such a good line of best fit. So the Desmos is doing it for us. So there's the points. Now copy down the m and the b. That's going to be used to create your equation. So then my equation, I'm going to write, so my m was 5.07692. Okay, so once again, please do not write all of those numbers. 2 numbers after the decimal is fine. So 5.08, because that 6 is bigger than 5, so we round up. Write the x, plus 46.23. And now for the positive, negative, or no correlation. The hours of studying increases, and so do the test scores. So 2 up arrows is a positive correlation. Okay. So if you notice, I use the word positive, so I answered the question. And then I use the word increase and increase, because 2 increases is a positive correlation. You can also check that if you look at the slope right here is a positive 5. So that's how you know it will go be a positive. And also you can check your data set in slide number 7. And notice that it is trending upward, up and to the right. So that's also a positive correlation because it's going up and to the right. So that's another way that you can check. All right. If you have any questions, make sure that you email us. Thank you.